defense and civilian decision makers in the space domain are thinking through the future of their operations, from workforce to budgets to tools and beyond. Joining me today, we have Major General Kimberly Kreider, Mobilization Assistant to the Chief of Space Operations at the United States Space Force; Tim Self, Deputy Director of the Network Cross-Functional Team for the Army Futures Command; Nicolas Chillon, Chief of Software at the Air Force; and Philomena Zimmerman, Director of Engineering, Tools, and Environment Office at the Deputy Director for Engineering, Deputy Director, Undersecretary for Research and Engineering. Thank you all for joining me today. First, let me go down and the line here. Have you all very briefly introduce yourself to the audience, talk a little bit about what you do, starting with you, General.
Thank you, Patrick. Thanks everybody for having us here today. It really is a great opportunity for the Space Force to be here with you. So as Patrick mentioned, my official title is the Mobilization Assistant, meaning that I am a reservist. I work directly for the Chief of Space Operations. But these days, I'm spending all of my time supporting the Space Force, the Chief, in the stand-up of the Chief Technology Innovation Office, which is where we are centralizing all of our focus on digital transformation across the service, our focus on science and technology planning, our collaboration with the Air Force on IT infrastructure and platform capabilities and data and analytics, as well as our focus on applied analytics and analysis. So the CTIO is the headquarters level function that is responsible for planning all of those activities, strategizing those activities in collaboration with our field commands out at Peterson Air Force Base, the Space Operations Command, and our Space and Missile Center out in LA. It's a pleasure to be here. Thank you so much.
Thanks. Let's go to you, Tim.
Hey, afternoon, everyone. Again, thanks for having me. Look forward to the opportunity to participate in the panel. As mentioned, I'm the Deputy Director of the Army's Network Cross-Functional Team. We're kind of a small team of experts in areas of acquisition, science and technology, resource management, testing, requirements, and even members of the operational Army community. And our mission is to have a focus on innovation and driving Army modernization, bringing in partnerships from the rest of the Army modernization team, so that we push a modern Army network. And that modern means it's joint enabled, it's coalition enabled, it does everything we need to fight and win the next conflict.
Okay, great. Thank you, Nick.
Hey, thanks for having me. I'm Nick Shaw. I'm the Chief Software Officer of the Air Force, and I'm also the co-lead of the DoD Enterprise DevSecOps Initiative with DoD CIO and OSD ANS. And my job is to make sure we're moving at a pace of relevance and helping teams move to DevSecOps and Agile and try to remove impediments on their way to do just that at scale. And so we are leading with the Cloud One and Platform One to bring enterprise services for DevSecOps across the DoD.
Okay, thank you. Philomena.
Hey, thanks everybody for having me here. My job is to work behind the scenes, behind the operational piece, to actually change the way we engineer, build our systems, and what we provide to the warfighter. Not just the end result, but also the digital artifacts that can be used in analysis, mission preparation, rehearsal, etc. I'm the lead for digital engineering for the department.
Okay, great. So, ladies and gentlemen, we have, as you can see, a very full panel here this afternoon, and we anticipate a brisk, very informal, hopefully enlightening discussion. There is an opportunity for you to submit questions. I don't know how many we're going to be able to get to today. If you have one, please submit it, though. It's just good to have and can help our panelists to know what's on the minds of viewers out there, stakeholders, et cetera, as they think about how to pursue their different missions, objectives, and projects. So use the question tab. We'll try to get to them. I can't make any promises because we've got a great four-person panel here and precious little time. So thank you for joining us. And let's start off, General. In thinking about what all of you have in common and also the future direction of the department, really can't overstate enough the importance of multi-domain command and control, the direction that the department is going with that, all of the work that it's doing right now across the services, that the services are doing individually, and that the department overall is doing. If you're watching from home and you're not sure what that is or what that refers to, basically the Department of Defense has launched on an incredibly ambitious project for really the next 10 years, but it's a process, and you can expect to see some milestones along the way be met, of interlinking all of the different things that it has in space, in the air, in cyberspace, on the ground, on the sea, across all of the departments, across all of those domains, linking them together in kind of a massive network to enable operators and commanders that are possibly engaged in a conflict with a very high-tech, very well-financed adversary, to enable them to use all of the different things on the battlefield in the most effective way possible to basically make warfare much faster and much more effective for our side. This whole project, you could call it JADC2, Joint All-Domain Command and Control. It's now called CJADC2 in some areas of the Pentagon, to reinforce that it's a combined effort, also bringing in potentially allies across NATO or other partnerships. Huge effort. And we've been watching some progress along those lines. The Air Force has done a number of different experiments this year with what's called the ABMS, Advanced Battle Management System. That's their little contribution to this larger endeavor. And I guess we very recently finished an on-ramp, General Kreider, for the ABMS. Tell us a little bit about what you saw in the third on-ramp, the really big one, and how Space Force in particular is helping to shape the future of this joint all-domain idea.
Okay, thanks, Patrick, and thanks for that introduction. You did a good job of kind of laying that out a bit. Just a couple of things to clarify. And oh, by the way, you see me here. I'm at Air Force Research Lab today, calling in to this session because we've been spending some time here the last couple of days talking about all of our research initiatives that the Space Force is embarking upon with the Air Force Research Lab. And you know, Joint All-Domain Command and Control, ABMS, is a critical concept. You know, JADC2 really is a joint concept that all of the services are committed to under the joint staff because it really is about fundamentally how do you get all of the services to be able to interact in this highly integrated all-domain environment where you can effectively command and control capabilities, command and control data from any sensor to support any task that you might need to do. And as Patrick mentioned, the Air Force, the Department of the Air Force, has been launching off on the Advanced Battle Management System capability, essentially a tech stack that brings together data from any sensor, integrating it into a highly integrated technical capability to include networks and platform services and cloud-based services, data environment, applications and AI, all working in concert to provide those commanders the ability to make decisions, leverage information, apply analysis and analytics, and be able to better understand what's happening across any domain to be able to task and maneuver and work within a highly competitive and contested environment. And so the department has been moving out on ABMS. The Air Force and the Space Force, two services within the Department of the Air Force, have been working together through these various on-ramp exercises that Patrick mentioned. The second one was really the big one, happened in September. There was a third one, much smaller event focused in the Indo-PACOM region, very condensed because of COVID restrictions. So I'll speak, I think, predominantly to the second one. Happy to answer questions about any of the on-ramps. But the second one was really the big one. This was in early September where a lot of activity came together. It was a very exciting event. We had the Space Force actively participating with U.S. Space Command as a combatant command in both a supported and a supporting kind of a role. U.S. Space Command, of course, is the warfighting combatant command that has the responsibility of really conducting operations in, from, and to the space domain, and protecting and defending space assets, preserving and assuring space capabilities, and delivering those services to other joint warfighting operations, to include things such as SATCOM, navigation and timing, ISR, et cetera. So space as a warfighting domain was featured in this on-ramp, and its need to be able to function with other domain partners very effectively to be able to deal with what are, very rapidly increasing and advancing threats to our space assets and threats to other assets in other domains that space can support the protection of. Space is fundamentally an all-domain fight. We have to leverage information from other domains to understand what might be traversing those domains or impacting those domains that touch space. We rely on communications on the ground. We rely on communications in the air domain. And certainly we rely on our assets in the space domain. So we really have to communicate and coordinate across every domain. And this particular on-ramp gave us the opportunity to demonstrate how important those other domain partners are to us. If a space asset on the ground is being jammed, how do we coordinate an effective, first of all, how do we understand where that jamming source is coming from? How do we geolocate on it? How do we leverage other domain assets to help us zero in on where that potential jamming source may be occurring? And then how do we quickly remove that threat, remove that problem by leveraging, again, maritime or air or ground resources to help us take that out in the most efficient way possible. That's what we refer to as supporting the space domain warfighting operation. Is if space is being impacted, how do we leverage other domain assets to support the ability to keep space available and to keep space working very effectively? What we saw in this on-ramp, just in the space example, in that case, was because we could quickly identify threats, pulling data from other domains, we could quickly coordinate with other partners in removing those threats or getting out in front of those threats. We were able to essentially what we refer to as close the kill chain. Any particular threat, we could remove it really in a matter of seconds, which emphasizes how valuable working in this highly integrated joint environment with technologies today that allow us to work very seamlessly in this technical stack in a way that we couldn't, very well previously before, to be able to operate in a much more effective and efficient manner. And we saw similar sorts of rapid results from the other domain partners that were participating in the on-ramp. The whole idea of being able to rapidly close on kill chains because you could more effectively move seamlessly in this coordinated manner.
Yeah, thank you so much, General. A good point on on-ramp 2, the big one, as they say, the Super Bowl of the on-ramps. Did that on-ramp, and then I'm going to go to Tim to talk a little bit about Project Convergence, but did that second on-ramp give you a sense of how much larger the demand signal for space assets is going to be in a more multi-domain type of construct? How much are all of these different services trying to work together across all these demands? How much need are they going to have for space assets compared to what you see today?
Well, we've always known that space is a high demand capability set. This on-ramp only re-emphasized that. Every operation today depends on space. And many of our operations rely on space for, as I mentioned, communications, position, navigation, and timing, ISR support to their operations. So that was certainly emphasized in this on-ramp. I don't know that we quantified that pull from space, but throughout all phases of the operation, it was very clear that every aspect of the operation depended on space. Space needed to be available, and space was therefore highly prioritized in its joint all-domain needs to be able to be supported so that it can continue to ensure that those services were always available.
Okay. Well, let me go to you, Tim, because the Army is also engaging in a big project, Project Convergence, to develop new realities of cross-domain teaming for the Army. It was, I got to go down to Yuma and watch it. It was very exciting. And a couple of the takeaways for me, just watching that happen, is that, yes, using different tools to take lots of incoming data, fuse it, and then output that, it did allow the Army to much more quickly identify and then strike at different targets, sort of collapsing the time it takes to do that rather dramatically, I thought, even though not all the targets were reached, many of them were, and you did see that collapse in the time. But it also showed me just how reliant the future Army is going to be on the network cross-functional team, especially as it looks to engage with more autonomous or semi-autonomous ground vehicles or even air assets that will have an ISR function or some other function. So what was the big takeaway for you in terms of what Project Convergence, the great big cross-functional team experiment that just got wrapped up in Yuma, what's the big takeaway for you in terms of where the network priority is right now and what needs to happen in the next couple of years?
Yeah. First of all, let's sure we understand Project Convergence is really just a capstone exercise, right? It's part of a campaign of learning. So there's several risk reductions into it, other events, joint events like the JATC2 experiment that lead up to the Project Convergence where we bring it all together. But yeah, as you mentioned, what was very obvious there is that the network enables a lot of the functions that we're trying to get out of the JATC2 stuff. And that being, I think, the catchphrase you'll hear is all sensors, the correct shooter with the right C2, and forming a network that allows the operators to see the environment, see the targets from various sensors and bring that together. Several sensors might be looking at the same thing, picking the right weapon system to engage it and making that decision at the right place because, like everything, weapons kind of are resource constrained often. So we just don't want things firing. But again, the network enables all of that. And it's not just the transport part of the network. It's really, my boss says it a lot. It's all about the data. Where are we collecting data at? How are we transporting that data across different nodes? Where are we copying at for resiliency? What kind of tools, IA or machine learning tools do we have that helps turn that data into information or ultimately knowledge? Again, so commanders can make decisions based on informed data that's out there. So that's really what it's all about. In my mind, we're not going to win the next conflict by having the best network. The network is just going to enable us to use our weapon systems and our sensors and our will in better places to win that conflict. So it is, we kind of learned it's very much an enabler, but it's a very strong enabler. In fact, I think most of my team would tell you that by the time we got to that last week of Project Convergence, we were a training tool so everybody else could apply their craft at that point. If the network wasn't running them, then, it wasn't going to help us to keep troubleshooting and stuff. So, and I think you kind of mentioned that it's an enabler across all of these domains.
Great. Well, let me turn to you, Nick, because one of the things that I think is so important here when we talk about what the future of joint all-domain actually means is, and Phil can be thinking about it and answer this too, is the importance of interoperability among lots of different types of machines. The Air Force is moving out with as you say, like a singular software platform. There's also a cloud architecture that is there to help be the kind of central node for all of this incoming data about how platforms are operating, about what they're doing, about what they're seeing, what they're sensing, what's on them, fusing all of that together in terms of creating an output that a commander can actually use to find that enemy that's out there jamming the space signal, et cetera. What is the biggest challenge right now in terms of creating a network that can accept all of these different, perhaps heterogeneous data types, turn them into something that can be then run through possibly machine learning or artificial intelligence kits, and then output a recommendation? Where is the big network challenge in that? And where is the Air Force right now in meeting that challenge?
Yeah, you're spot on. I think we have a couple of big challenges when it comes to the silos of the Department of the Air Force, and often the way we cut our networks, right, between classification levels. And now we're trying to reconnect everything into some type of cohesive way by using open architecture and like you said, connecting this Internet of Things network across DoD. Funny enough, we are kind of breaking the silos that we created to begin with. And, I think that the technical piece of that in terms of transformation of data and all the collection of data is pretty straightforward. I don't think it's very complex. We have a lot of great stack with the partnership with the Space Force on UDL and the Data One stack and Feed One stack, which is doing that feeding and streaming of data, and then that storage / data lake / data warehouse capability. Using a lot of open source tools, I think it's pretty straightforward. I think the biggest issue we're facing is honestly the connectivity piece, even basic networking that it just doesn't scale, very, very small pipes. And then on top of that, you add the issue of classification. And what you don't want to end up doing is overclassifying the entire thing. So everyone would have to have the TSSCI clearance or SAP clearance to get access to meaningful data. And so you really want to try to connect things using a zero trust mindset. And so Platform One and Cloud One build kind of that capability with that in mind to really empower the teams to piggyback on the zero trust culture, which really enforces both the device state that you're using, your need to know / role-based access control, tying that back to a cyber risk to whitelist access to resources. And what's interesting, it's not just people accessing data in this case, it's also legacy and more modern systems talking to each other. And so we're bringing a single sign-on stack that's going to be able to authenticate both people and machines in a secure and efficient manner, while enforcing that zero trust stack as well.
Yeah, that sounds like sort of exactly the sort of big, enormous challenge that a lot of people aren't going to see when they think about something that on its face sounds relatively simple, getting lots of things that are made for the United States military to communicate with one another. It seems like, oh, well, we're just talking about objects that are all part of the United States military. They should be able to communicate with one another. But as you point out, they're all made different manufacturers. They all have, in many cases, different protocols or standards for accepting data, for transmitting data. And then you have this issue of classification. It's something that the military top leadership is talking about more and more. General Hyten, the Vice Chief of Staff, has raised this as kind of one of the critical issues for the US military going forward, is figuring out how not to overclassify things and how to be much more agile in classification in general. So with that, let me turn to you, Phil. From a digital engineering perspective, we're hearing about the need for interoperability. We're hearing about the challenge of these big data silos. What has to happen from a digital engineering perspective to overcome some of what you're hearing in terms of the obstacles to really realizing a joint all-domain vision?
Yeah, that's a great question. And I gotta say, I love going last on panels with smart people like this, because usually I can say what he said or what she said. In this case, maybe I'll embellish just a little bit from an engineering and maybe set up General Kreider actually for a continued discussion. From a digital engineering standpoint, what we want to make sure is that when the warfighter gets to their live exercise or even their live event or worse yet, live on the battlefield, it shouldn't be the first time that they're questioning whether or not all of their systems can interoperate with each other. And what digital engineering seeks to bring to the table is the ability to test the systems, to experiment with the systems in a relatively safe virtual environment, so that we can work out as many of the kinks and problems with, even open systems architecture isn't a guarantee, but so that we can do the experimenting with these systems in a safe environment, so that we give to the warfighter the systems that they need at the time that they need it to do what they need to do with it. One of the things that we discussed briefly the last time I had a chance to engage General Kreider was to remind everybody that digital engineering doesn't seek to be in the forefront. As a matter of fact, the word that Tim used was enabling. We're one of the background enabling capabilities that frankly you shouldn't see when you get to the battlefield, and you shouldn't even know they existed. But if we do our job right, the warfighter is going to get to perform the way our warfighter needs to perform at the point of need. Over.
Yes, thank you. Let's turn that to General Kreider. In terms of understanding how well different objects are performing and interoperating, and how well they're accessing those space assets, tell us a little bit about the role of simulations, of modeling, and versus the role of some of the live demonstrations like the ABMS on-ramps. How much more experimentation can be done now in a virtual environment compared to a live environment? And what are you learning from that?
Well, thanks for that, Patrick, and thanks, Phil, for some of your lead-in as well. I appreciate that. We're not where we want to be yet with digital engineering and with modeling and sim. We've been doing modeling and simulation kinds of things across the services, across the DoD for quite some time. But in terms of a fully integrated environment where we can rapidly apply models and rapidly ingest data and rapidly develop new capabilities on the fly to respond to ever-changing threats and fully model and understand that threat as it evolves and do that all virtually and connected. We're not where we want to be yet, but we're certainly moving out very aggressively across all of the services to do that. And when we do that, as we do that, we are going to, in many ways, be able to create a more real environment than what really exists out in the real world, because we'll have so many more options that we can play. So to Phil's point, when last thing we want to do is have the warfighter be surprised. Now, we've learned how to deal with surprise. We've learned as warfighting entities to be able to be very effective at trying to stay ahead of the surprise. But there are surprises that happen in operations. And if we can create the reality of here is what reality looks like that the warfighter can't even see yet. Because we can model all of those contingencies, or we can model all of those potential events that could happen. And then we could run those models against our systems and against in our testing environments and in our engineering environment, so that we can manage all of the different trades and manage all of the different risks in new and innovative ways. We can create solutions that will always be out ahead of those potential surprises. And that creates that much more of a robust capability for us. So that's the kind of capability that we're really moving towards, is how do we create environments? How do we work in environments where it's just natural for us to have access to data and models that can be more realistic than the real world, because we can stage and look at everything that could potentially exist. And then be able to develop any number of options and solutions to work through those various contingencies.
Yeah, it's a fascinating time for it, for the idea of higher resolution, more credible models and simulations for a lot of different things. A couple of years ago, I think it was, then Undersecretary of Defense for Research and Engineering, Michael Griffin, made virtualization and digital engineering a big part of what he was pushing for in changing the Department of Defense. And as you point out, we're not exactly where we want to be yet, but the next couple of years, I think that a lot of people are going to become more and more familiar with terms like digital twinning, especially in terms of designing things like aircraft. Air Force recently announced that they've actually test flown an experimental Generation 6 aircraft. And they didn't say a lot about it, except for the fact that new techniques in digital engineering, like digital twinning, were essential in helping them do something that, with the last aircraft took a decade to do, is reach something at a prototype level, like where you can do a test flight. So the virtual world, all the data that goes into creating a credible scenario, into creating, whether it's for designing an aircraft or designing a battlefield simulation, it's incredibly data intensive to do that. I mean, there's a lot that needs to go into it. And I wonder if, I might turn to you, Tim, and talk a little bit about how the Army right now is using simulations as part of its role in understanding the future of joint all-domain operations and understanding interoperability among all of those different things that they're pushing out into the battlefield that they want to communicate with one another and communicate back to command in other places.
So we're pushing forward very much now with what we're calling the CGS2 Hub, where we are connecting all of our labs together, and many of those labs have modeling and sim in the background that drive the environment that they're experimenting with. And that will include reaching out. I know we've made contact with the Air Force to bring some of their labs into that same hub. So we have a persistent environment of laboratories with model and simulation, creating that virtual environment to allow them to do that experimentation. But I think the other thing the Army's really realized is, the virtualized environment is only as good as it replicates the real environment. So you'll see it a lot, in Project Convergence, especially where we're collecting data of the real environment and feeding that back into the virtual one so they can better model what it really is in the real world. Because one of the things you'll never get, and why our capstone I think will always be in the field with live soldiers is, the virtual environment soldier, he doesn't get hungry, she doesn't get tired, she pushes all the right buttons. Unless you've really done a good job in that environment, they drive their vehicle in the right direction every time you tell them to, right? And we see in the real world that's not the case. Soldiers do things that the virtual environments do not do, and as much as we can feed that back and replicate that back in, the better off we are. But there will always be, I think, the capstone will always be what we call soldier touch points. Project Convergence being an example of that, where we put the equipment and the technology in soldiers' hands, and we're doing that a lot sooner now than we have in the past when it comes to traditional acquisition processes. We're putting it in their hands, we're getting their real world feedback, and again, we're coming back and not only adjusting the equipment that we're looking at putting in the field, but we're also adjusting the models and the sims that are helping inform that next cycle. But it's really a cycle back and forth between all those things.
Right. Yeah. The soldier touch points are so interesting. And I think just watching this space, it's so fascinating to see all of the different areas where modeling and simulation is going to affect the future of what everybody in the military does, from designing aircraft to, for soldiers, one of the features of the IVAS mounted head display, it's the new Microsoft, it's kind of a heads down display. It's going to replace night vision goggles, is that you can role play and essentially rehearse different scenarios based on how well you performed in that scenario last time, how well someone else performed in that exact same scenario, possibly in that exact same location. So you get to kind of, play level 32 of the Abbottabad compound, though that's a Navy thing because the Navies were there, like as many times as you need to before you actually embark on a mission, because you have that data that's informing a scenario that you're able to role play over and over again with this headset. And it also goes to designing aircraft and things like that.
Yes.
So all of that is great, but I want to turn back to something that Nick said, because Nick highlighted a couple of problems that are unique to what he's experiencing right now in his role. And I think that they also apply to what you, General, are doing, and you, Tim, and that is the problem of data siloization and the problem of overclassification. So I wonder if both of you can quickly let us know where you are right now on those problems. Do you perceive them as big obstacles to better integration and better performance in terms of your domain? And what can be done about them now and in the years ahead?
Are you asking?
Who are you asking?
Go ahead,
Well, the highest ranking first, so you, General, please. Thank you.
Well, I don't know about that, but I guess I was the first to speak up. So silos and stovepipes of data is definitely a challenge that we all face because we rely on data from so many different places, and we're not all fully integrated yet when it comes to how we share data. I will say, and Nick mentioned this, that the Space Force has been moving out quite aggressively for the last couple of years in breaking those silos. With the establishment of our Unified Data Library, data lake environment where we can access data from any domain and publish and make that data available. And now bringing that forward into ABMS as a key component of Data One, that large data lake, data sharing capability set, adding to it the Feed One capabilities for live streaming to be able to allow users to subscribe to specific data sets is certainly critical to breaking down those silos. It's been important to space for a long time because we have lots of sensors and we have lots of needs to get that data moving around. So breaking through those silos has been kind of the driver for that initiative that now the all domain capability is taking advantage of. But sure, it's an area that we all need to continue to work. We're working now extending Data One out to federate with other data environments. We're talking to the Army about federating with their data environment so that we can share data across large data environments and collaborating closely on those kind of ideas as we look into the future and federating out to continued partnership with the IC community and others for more ways to provide access and break through some of the stovepipes that might exist.
Okay, Tim, sorry to cut you off, Tim. Please go ahead.
No, it's okay. I think we're approaching it with what we call a data framework approach, and especially in the S&T world. So, the reason some of those silos exist is because people or systems need different data based on their mission. Certainly a fire control system that's calculating a warhead and a trajectory needs something different than a C2 decision about whether I want to engage that target or not, right? So, and you're right, in the past, everybody kind of built their own database to support their mission. So what we're really trying to do is bring those together. And I think there's kind of two approaches to it. One of it would be, let's all fall in all on the same data model. And for various reasons, that's kind of hard to do. Everybody likes their data model. But I think the approach you're seeing in the S&T world is more data mitigation so that the data fabric has access to all those different databases and mitigates the difference or puts it in a form that AI can use, machine learning can use, anybody else can pull. And then that brings in that multi-security domain piece. If we can mitigate the fields of the data and decide which ones are in which security domain and which not, because again, right now we're kind of saying, hey, this whole database is classified at a certain level just based on the whole database. And if we can pull that out into a data fabric and say, well, no, there's really only two fields here that are classified different than what we really need. And how do we control access to just those two fields and let the rest of the data be exposed to the rest of the community that needs it or could use it. And we're seeing that approach. I'm seeing that approach a lot in the S&T world now is again, not try to collapse everybody, but let's try to make sure we can mitigate. And, if somebody has 8 fields to describe that object and someone else has 10, at least we know which ones are the same. And again, which ones are secured higher than others and expose that data to other people and across services also. Yeah.
So you bring up artificial intelligence and machine learning, and I have a great sense of how they're playing a role in the future of the Air Force and the Army. And Phil, I wonder if you can talk a little bit about the role of artificial intelligence and machine learning and possibly neural networking in digital engineering in the Defense Department. Is it redundant to say that digital engineering and artificial intelligence are sort of the same thing, or what is the role for AI in engineering digitally in the next few years?
So goal 3 in the digital engineering strategy that you mentioned before talks about technological innovation in our engineering techniques. And on the first way that we're actually embracing artificial intelligence and machine learning is to augment the digital techniques that we have today. And so anything that we can do that would help, for example, a simulation or a model execution to run through all of the different, the multidimensional parameters that it has to create the decision space for decision makers is one obvious example. They are not at odds with each other. As a matter of fact, they are complementary. You can't do AI or machine learning without being digital or computationally based. And frankly, we can't even take advantage of combining those two concepts or those two techniques unless we have the infrastructure of the likes that Nick provides to the Air Force. Neural networks, again, a same sort of thing. It is a complementary technology to the warfighter, to the engineer, to the analyst. And it's all about being digitally based. So they're very much supported by the shift to digital and to rigor in the Department of Defense, but they're also useful technologies that we can bring to bear in the curation of our models and our decision analysis sets.
Yeah, interesting, because covering this space, I'm always, as a journalist, I'm always really attracted to those use cases where an AI in the field, in the hands of a commander, did something miraculous, like for Northcom, predicting potential lack of protective equipment in locations around the country as part of Northcom's COVID response. Like, that's exciting. Or predicting this or that for different commanders, that's exciting. But AI and machine learning actually have a role to play in a lot of the sort of behind the curtain processes that we're talking about here. And Nick, I wonder if you could talk a little bit about that too, because software design, you're creating the spaces virtually for all of these different data to come together to be useful to all of these platforms and to all of these commanders so that it's useful for artificial intelligence. But does AI play a role in what you are currently building and doing? Do you use it as well in designing software within the Air Force?
Yeah, absolutely. No, it's a foundational piece of our cyber stack as well. Everything we do on the zero trust and continuous monitoring side is piggybacking on AI machine learning capabilities when it comes to behavior detection and continuous scanning and detection of bad behavior from bad actors. So the platform one stack is 100% based on AI machine learning capabilities that are continuously monitoring the stack. And back to your point on the data piece, right? I think it's very important to understand that obviously collapsing networks is never going to happen. I really like team's idea of data labeling down to the field level, so we can really understand what is really classified here. And it's funny how often an entire system gets classified only because 2 fields out of thousands are classified, and that's just exactly what creates these silos. And honestly, then we are left having to break those by connecting systems together and try to find ways to mitigate that problem, which is really not a technology problem. I think we have the technology. It's mostly a policy / risk understanding of declassification, or at least better classification. The same thing with the source code, right? You see teams that classify now, overclassify source code. Even more so when you move to microservices and containers and you have very small set of people that get access to the entire system, there is less need to classify or overclassify that source code because now you're mitigating that risk by having less people having access to the entire system and only having access to Lego blocks that we call containers. And so really at the end of the day, maybe the system running in production ends up being classified, but the source code very, very rarely needs to be classified because very, very rarely do we have software source code that is actually using classified techniques. And so You know, that just makes it harder to find talent and find people that we can bring on board, like me, you know, from the commercial side, that can help us move faster together.
Ah, fascinating. Yeah, you know, it's an area that again, artificial intelligence is going to change rapidly in the coming years. I read a paper back in 2016 from a data scientist, and he actually figured out an algorithm that would tell you if you took a piece of information and you factored in the number of people that knew about it and the amount of time they would have to restrict that information, you could actually predict how long a secret would stay a secret. And it speaks like kind of directly to what you're talking about in terms of the traditional kind of risk-averse approach that the IC and the government has had, and how that risk-averse approach has led to a kind of reactionary overclassification of data, of also different pieces of information. In the years ahead, you'll be able to take theoretically an informed risk approach that will tell you when and how to classify things, if they can be classifications for different purposes or that last different durations. And then that would allow the serving of data and information to different people at different times, and much more rapidly allowing classification to be actually useful rather than kind of reactionary. So I look forward to that. It's a very bright future for many of these things. And with that, I want to thank you all so much for participating in this panel. This was great. Major General Kim Kreider, Tim Self, Nicholas Shillon, Philomena Zimmerman. Really appreciate your taking the time today to talk to all of us about what you do and the future of the digital space in the Department of Defense. I would like to turn it over to Danielle Thayer, publisher of Defense One, and Josh Jackson, Senior Vice President of SAIC's Operations Defense Systems Group. Daniela, over to you.
First to our editorial panel. Hi, I'm Daniela Thayer, publisher at Defense One, a division of Government Executive Media Group. And it's my great pleasure to continue the conversation with my guest, Josh Jackson. Josh is Senior Vice President for the Naval Business Unit at SAIC. Josh, welcome and thanks for chatting with me today.
Oh, no, my pleasure. Good to be with you.
I thought we'd start off, rather than my reading your bio and distinguished credentials, I'd love it if you'd just tell our audience a little bit about yourself, your career, and your current role at SAIC.
Sure. So I've lived in Virginia most of my life, so I claim that as home. And we love living near DC, enjoying all that it has to offer, and especially love being close to kind of the action of the government. And that's one of the reasons why I enjoy being supporting the defense industry, which I have most of my career, making a difference in the lives of citizens and actually making a difference in the security of our country. I've been with SAIC for 18 years. And in that time, I've done a wide variety of roles to include running programs that support defense weapon systems, both small and large, as well as running horizontal businesses, which was actually before my most recent one. I led the Solutions and Technology Group, where over the course of a few years, really developed a passion for digital transformation and how digital transformation can enable mission effectiveness and larger transformation efforts across the Department of Defense. And then most recently, I'm now leading SAIC's Navy business.
That's great. It's great to share with the audience sort of where you're coming from. Today we've been talking about space, so I wanted to ask you to comment on something that General Raymond recently stated. He, of course, is our first Chief of Space Operations, and he wants the Space Force to be the first digital force. So tell us, from your perspective, how does the DoD prepare to be a digital force? What does that mean?
So I think to prepare to be a digital force, and more broadly a digital organization, we have to take a short and a long view simultaneously. So in my mind, the short view, right, is really enabling quick wins, where digital enables what I call micro transformations that save time, money, or enable mission effectiveness, kind of on a small scale. And this is really enabled by empowering teams, right, to experiment with new architectures, new technologies, new organizational constructs or TTPs. And kind of, we have to incentivize them to accelerate that reach kind of to new levels of embracing what digital has to offer. But we also have to take a long view while we're taking that kind of quick win view as well. And that's more complicated, right? But I think it involves having a holistic view of digital transformation at scale. And for the DoD, that scale is massive, right? And it's highly complex. So in my mind, a holistic view of digital transformation, we have to look at an organization, we have to look at the technology, we have to look at the people all together and first chart a course for that transformation and then rigorously execute that plan. We often get fixated on technology and we miss the other elements that enable transformation, which is the organization in which we operate, right? In this case, the Space Force for General Raymond, as well as the people and the technology and how you put all that together in a holistic fashion, right? You know, the data show that more than 70% of organizational transformations fail because we lack a holistic approach, right? So I think a successful digital transformation that I've seen and that I've been a part of, right, we focus first on cultural transformation and cultural changes required to unlock the larger digital transformation. So I think you have to take a short and a long view, both geared towards laying that foundation for fundamental change.
So in looking at it from that perspective, sort of a high level view, that holistic view that you mentioned, regardless of, for example, the outcome of the election, legislators in general, right, are turning their attention to budget and what these things cost and how digital transformation and digital engineering could benefit budgets. Can you talk a little bit about that and the efficiencies that can be gained in looking at it from that perspective?
Sure. So no matter what happens in terms of administration, right, I think one thing is there's not going to be enough to do everything that we want to do. We as an industry, we as a Department of Defense more broadly. So we're going to have to prioritize and make some hard decisions and choices, right? And embracing digital approaches can help, you know, from a capability development perspective. And I think I'm seeing a lot of good traction in DoD leaders embracing digital as they seek transformation. So I'm encouraged by that. I think one of the specific ways that digital can be beneficial from a budget perspective is that it enables experimentation at higher degrees of fidelity, you know, oftentimes for less money and over a shorter period of time. For example, we can build, you know, a digital twin of a complex weapon system and experiment and test it virtually. And we can iterate on that design over and over again in a very short period of time, oftentimes changing how we might employ that system as well, which is a pretty cool thing. So I think there's some tangible outcomes and benefits of that, but really you've got to, you know, you can reduce the cost of that weapon system development and you get a chance to inform, you know, higher level portfolio decisions that the Defense Department is grappling with on a regular basis. You know, an example of that is the Commandant of the Marine Corps is employing, you know, sophisticated gaming as an approach to redesign and refocus the Marine Corps. But I would also think that another area where digital benefit discussion is the fact that we can take modular and composable approaches. As we kind of push towards software-defined everything and open systems architectures and approaches, it allows faster upgrades of systems, right? We can't afford the days of 5 to 10 to 15 year major systems development efforts. And we can't afford creating systems that are fragile. So I think that's where industry can play a role with DoD, is that we should open architectures and approaches. And this is going to allow us to reduce the cost, both on the development side as well as the tail for major systems, because it increases interoperability at the same time.
So Josh, you mentioned speed. tell me, how do you see speed, innovation, and agility affected as we move digital to the edge?
Yeah, so we walk around every day with a pretty powerful computer in our hands, right? That allows us to communicate, run analytics, translate information, view and contribute to common operating pictures, right? Which is a common DoD term, but Waze itself is a common operating picture, right? Cities all around the globe are launching smart city initiatives. Right, that's the Internet of Things, right? Same is true for Internet of Battlefield Things, which is something that we've been thinking a lot about at SAIC, right? And as we enable digital at the edge, we're going to speed up decision making, right? So speed is a big factor that it's enabled, and it potentially allows us, to take steps out of the kill chain, so we can generate effects on the battlefield faster, right? So speed's definitely there. And then innovation and agility, right? Kind of think about those together, right? As we employ and use edge services in an increasing number of places, as well as capacity, right? The ability to innovate and demonstrate agility also increase, right? For example, you can enable teams and squads the ability to run local analytics, right? That are leveraging local intelligence. But also have access to a larger data set for that operational context that's so important, right? And then by doing that, right, we're enabling individuals as well as teams at the edge to pivot more rapidly, really increasing their effectiveness as a small unit. So I think speed and innovation, right, all enable positive things, from edge as the edge comes alive with compute. Kind of the cloud and the fog and edge components all working together. But again, I'd be remiss if I didn't mention, it's not just about the technology, right? You have to be willing to embrace the cultural and organizational and operational changes that are also enabled by digital for it to truly be transformational.
Josh, I really appreciate your time today. I think your perspective on all of this has been very interesting to me, and I'm certain to our audience as well. Thank you so much for joining me, and thank you to SAIC for making today's event possible. I hope our audience enjoyed this discussion, and we hope that they will also join us for the next, third, and final installment of the Defense One event series in this underwritten by SAIC, and the next installment will be coming out very soon. So until then, thanks again.